electrolyte molecules are split into two types of charged particles. These particles are called as ions, and the process was termed as ionization. The positively charged particles are called as cation, and the negatively charged particles are called as anions. The theory assumes that the ions are already present in the solid electrolyte, and these are held together by electrostatic force. When placed in water, these neutral molecules dissociate into anion and cation. So the positive is cation and the negative is anion. For that reason, this theory may be referred to as theory of electrolytic dissociation. The ions are present in solution constantly reunite to form the neutral molecules. Thus, there is a state of equilibrium between the undissociated molecules and the ions. AB will give A plus and B minus. Applying the law of action to the ionic equilibrium, we have A plus B minus divided by AB is equal to K, where K is called as a dissociation constant. Here is the example of electrolytes. Let's discuss more on the electrolyte. So here is anode and here is cathode, and there is a salt bridge between them. The charged ions are free to move through the solution to the oppositely charged electrolyte and electrode. This is called as migration of ion. The movement of the ions constitute the electric current through the electrolyte. This explains the conductivity of electrolyte as well as the phenomenon of electrolysis. The electrical conductivity of an electrolyte solution depends on the number of ions present in the solution. Thus, the degree of dissociation of an electrolyte determines whether it's a strong electrolyte or a weak electrolyte, or it's a non-electrolyte. Let's discuss on the electrolytic cell, how it works. We know that electrolytes dissociate in solution to form positive ions, cations, and the negative ions, that's anions. So as the current is passed between the electrode of the electrolytic cell, the ions migrate to the opposite electrodes. You are able to see it here. If we talk about the postulates of Arrhenius theory further, in the electrolytic solution of a silver nitrate, the cation Ag plus will move to the cathode, and the anions NO3 minus will move to the anode. Here is a silver nitrate solution. Usually different ions move with different rates. Here is a typical solution of copper sulfate. Copper is positive and sulfate is negative. Sulfuric acid, hydrogen plus and sulfur 2 minus. So let's think about the migration of ions through the electrolytic solution to opposite electrodes. The migration of ions through the electrolytic solution can be demonstrated by the following experiments. So the properties of solution of electrolytes are the properties of ions. The solution of electrolyte as a whole is electrically neutral unless an electric field is applied to the electrodes dipped into it. Presence of hydrogen ions renders the solution acidic, while presence of hydroxide ion renders the solution basic. There are two types of electrolytes. Strong electrolytes are those when dissolved in water are completely dissociated into ions of positive and negative charge. Then total number of cations and anions produced are equal to those in the formula of the electrolyte. So we got aluminium sulfate, we got aluminium ion and sulfate ion. Here are typical example of strong electrolyte: sodium chloride, potassium chloride and silver nitrate. These are the few examples of strong electrolyte. In the case of V electrolyte, there is a partial dissociation into ions in water, and an equilibrium exists between the dissociated ions and the undissociated electrolyte. Acetic acid is a weak electrolyte in water, and unionized acetic acid molecules are in equilibrium with the acetate ion and H+ ions in solution.